Good afternoon to everyone.
Sir.
Good afternoon. So, so the last 3 to 4 classes, the previous classes, I think maximum are 3 to 4 classes, I think so. So we are discussing linear differential equation with constant coefficients. Okay, there are 7 types we discussed. Okay, type 1 is right hand side is exponential function. Type 2 is right hand side is sin ax or cos ax. Type 3 is uh, algebraic function or polynomial x. Type 4 is e power ax into v of x. V of x is either polynomial or sin ax or cos ax. Type 5 is some polynomial into x into sin ax or polynomial in x into cos ax. Type 6 is polynomial, exponential, sin ax or cos ax. Type 7 is, you know, that those problem which is not comes under type 1 to type 6. Okay. Now, linear differential equations with the variable coefficient. Okay. So the coefficients are here variable. So the general form of Euler homogeneous linear equation or Cauchy linear equation is a naught x power n d power n y by dx power n plus plus a1 into x power n minus 1 into dn minus 1 d power n minus 1 into y by dx power n minus 1 plus a2 into x power n minus 2 into n minus 2 derivative of y by dx power n minus 2 plus and so on. So a n minus 1 into x into dy by dx plus a n y equal to right hand side function I will take capital X. This equation 1 is called Euler homogeneous linear equation or Cauchy linear equation. Okay. So it's more general form. The more general form of this equation is, so this is the more general form. Okay, a naught into bx plus c whole power n into d power n y by dx power n plus a1 into bx plus c whole power n minus 1 into d power n minus 1 y divided by dx power n minus 2 and so on. A n minus 1 into bx plus c into dy by dx plus a n into y equal to right hand side function is x. So if you substitute b equal to 1 and the c equal to 0 in this equation, you will get the previous equation, that is this equation, Euler linear equation. Okay, so this is a particular case of this equation. This equation, the name of this equation is called Legendre linear equation. The name of the equation 2 is called Legendre linear equation. So if you substitute b equal to 1 and c equal to 1 here, you will get Euler linear equation, Euler homogeneous linear equation or Cauchy linear equation. Okay. So now the main idea is here. First, you should convert the variable coefficient to constant coefficient. Once if you convert by using substitution, okay, variable coefficient to constant coefficient, now then you know the method how to solve. So for this, the substitution x is equal to e power z. This transformation will helps us to convert the variable coefficient into constant coefficient. So here, if you see here, I have take this x is equal to the small x is equal to e power z. Now I am going to convert Euler homogeneous linear equation uh, into constant coefficient. Okay, for this I am going to deal only equation 1 now. So later I will tell you when I will take equation 2 Now I am going to uh, convert equation 1 into constant coefficient. For this, I am going to use the substitution x is equal to e power z. Okay, so x is, I told that this, I'll take x is equal to e power z. Okay, then z equal to log x. Okay, if you differentiate with respect to x, dz by dx is equal to 1 by x. Okay, now dy by dx, what I can write dy by dx is dy by dz into dz by dx. So both are same. Okay, so now dy by dz, what is dz by dx? Dz by dx is 1 by x. Okay, dz by dx is 1 by x. Now cross multiply by x. So x into dy by dx is equal to dy by dz. X into dy by dx is equal to dy by dz. Now, or you can write x into, this is capital D, where capital D equal to what? D by dx. So d by dx is capital D. So x dy equal to, this is, somebody will take, this is theta, somebody will take d dash. Okay, the notation will differ. Okay, I will take theta. So where theta equal to d by dz. So d by dz equal to theta. So theta y. So x dy equal to theta y, or xd equal to theta. So you should remember this result. Okay, because to solve the problem, you should know xd equal to theta. Okay, the remaining thing is only for your understanding purpose, the proof everything. So next, I think here you calculated what? Dy by dx. Similarly, you calculate d square y by dx square. So d square y by dx square, you can write d by dx of dy by dx. Okay, now d by dx of, what is dy by dx? Here dy by dx is equal to what? Dy by dz into 1 by x. Dy by dz into 1 by x. So instead of dy by dx, so I use the previous result 1 by x into dy by dz. Here uv, so uv rule from here to here. So you should keep 1 by x here. If you differentiate dy by dz with respect to x, that is 1 by x into d by dx of dy by dz plus v is what? Dy by dz, differentiation of 1 by x. Okay, now 1 by x into d by dx of dy by dz is same as, this is same as d by dz of dy by dx into dz by dx. So this is a chain rule. So now these two are equal. D by dx of dy by dz equal to d by dz of dy by dz into dz by dx plus dy by dz. If you differentiate 1 by x with respect to x, you get minus 1 by x square. Okay. Now 1 by x, this is d square y by d square. Okay, d square y by d square. What is dz by dx again? Dz by dx is 1 by x. So dz by dx is 1 by x minus 1 by x square into dy by dz. So here also you have 1 by x square, here also you have 1 by x square. Uh, uh, if you take commonly 1 by x square and then cross multiply, you have x square into d square y by dx square. X square into d square y by dx square into is equal to d square y by dz square minus dy by dz. So we have this equation. Now you can write in the simplest form x square into d square by dx square is d square. This is d square into y equal to, this is theta square theta square equal to is d square by d z square is theta square, okay, into y minus this is theta into y, or x square d square equal to theta square minus theta, which is equal to, if you take theta commonly, remaining you have theta into theta minus 1. So you should remember this result. Similarly, x cube d cube is equal to x cube d cube equal to theta into theta minus 1 into theta minus 2. So x d equal to theta, x square d square equal to theta into theta minus 1, x cube d cube equal to theta into theta minus 1 into theta minus 2, and the x power 4 d power 4 equal to theta into theta minus 1, theta minus 2 into theta minus 3, and so on. So where capital D equal to d by dx and the theta equal to d by dz. So up to this, uh, we are converting the first equation, that is Euler homogeneous equation, to uh, using substitution we converted into constant coefficient. So now the same procedure we can use for Legendre linear equation. So here the substitution is, instead of bx plus c, we'll take z, e power z. Bx plus c equal to e power z. So z equal to a log of bx plus c. So dz by dx is equal to 1 by bx plus c into b. Now, so what is next? We need to find. So if you, so I will take here bx plus c equal to e power z. I got z equal to log of bx plus c, and dz by dx is equal to, if you differentiate this, you'll get 1 by bx plus c into b. What is next?
dy by dx.
Dy by dx. That's all. Okay, it's correct. Yeah, dy by dx. Okay. So dy by dx is equal to, you can write this is a dy by dz into dz by dx. Okay. Now, uh, next page I'll write. Sorry. Okay. So dy by dx equal to dy by dz, into dz by dx. Dz by dx is b by bx plus c. b by bx plus c. So now cross multiply by bx plus c, into dy by dx, which is equal to b into dy by dx, dy by dz. Okay, or you can write this is bx plus c into theta y, so not theta, dy, this is d y equal to b into d by dz is theta y. Or from this you can write bx plus c into d equal to d theta. Similarly, you can get find. So now next you should, sorry, yeah, so next you should find what, d square y by dx square. So if you find d square y by dx square, you will get bx plus c whole square into d square equal to b square into theta minus 1. Similarly, you'll get this. So there you have xd equal to theta, x square d square equal to theta into theta minus 1, x cube d cube equal to theta into theta minus 1 into theta minus 2. Here you have bx plus c into d equal to b theta, and similarly you will get bx plus c whole square into d square equal to b square into theta minus 1, and so on. But for exam point of view, you should remember these results. So if you forgot these results, so this proof will be helpful to derive this result. Okay. The first problem. Solve x square d square y by dx square plus 4x dy by dx plus 2y equal to x square plus 1 by x square. Okay. So now solution, we should start like this. First, it is better to write like this: x square d square plus 4x d plus 2 into y equal to x square plus 1 by x square. Okay, now so let us take x is equal to e power z, and z equal to log x. But you can directly write xd equal to theta and x square d square equal to theta into theta minus 1. So there is no need to derive these results here. So now substitute x square d square value, xd value in this equation. So I call this is 1. 1 implies theta into theta minus 1 plus 4 xd is theta plus 2 into y equal to x square. X is equal to e power z, x square is e power 2z plus 1 by x square. So 1 by e power 2z or e power minus 2z. Okay, now simplify the left hand side. The theta square minus theta plus 4 theta is plus 3 theta plus 2 into y equal to e power 2z plus e power minus 2z. What is the auxiliary equation? The auxiliary equation is m square plus 3m plus 2 equal to 0. So m plus 1 into m plus 2 equal to 0. So this implies m equal to minus 1 and the minus 2 are the roots of the equation. So what is the complementary function? What is the complementary function?
C1 e power x plus C2 e power minus x.
Lakshmi Narayanan. What you C1? Okay, e power e power
minus x.
think and
Minus
tell.
x.
Here theta is d by dz. Suppose if you have d square, originally you have d square there, so d square is what? D square, and so d is what? D is d by dx. So that's why there you are writing x here.
E power minus z.
Yeah, e power minus z. Okay, so c2 into what is your name?
Sanjay sir.
Sanjay. Okay, good. Okay, so minus 2z. So now we should convert into finally in terms of x only, c1 e power z plus c2 divided by e power 2z. So e power z is what? X. So cf is c1 by x plus c2 divided by x square. So this is for cf. Okay. Now pi. So pi equal to if I will take this is equation 2. So pi equal to 1 by theta square plus 3 theta plus 2. 1 by theta square plus 3 theta plus 2. Right hand side is what? E power 2z plus e power minus 2z. So this is type number. What's the type number? Huh?
2.
3 3 1
1, sir.
1.
1. Yeah, 1 is correct. So theta square plus 3 theta plus 2 into e power 2z plus 1 by theta square plus 3 theta plus 2 into e power minus 2z. Actually, so original equation is, this is the original equation. Using the substitution, we got, this is actually equation 2 is linear differential equation constant coefficient. You can check it. Theta square, before theta square we have 1, here 3. Okay, so you can easily solve this problem. What? So my work is over up to this. The remaining part, last 4 days I explained how to solve. Okay, so here onwards you should learn how to do it, solve these problems. Okay, so once you convert into z, finally again you should convert in terms of x. Okay, now this is equal to, so here you should replace theta by 2. So theta by 2, because type 1, 2 square is 4 plus 6 plus 2 into e power 2z plus here again theta by minus 2, so 4 minus 6 plus 2 into e power minus 2z. So this is equal to 1 by 10, 1 by 12 e power 2z plus this is actually 6 minus 6 0. So I will write 1 by 0 into e power minus 2z. Okay, so the next step I will write here. Okay, 1 by 12 into e power 2z. Okay, plus what we will do now.
Is that into e power minus 2 is
Correct. Correct. So you should multiply by the independent variable z. Okay, there you will multiply by x, because x is the independent variable. Now here you should multiply by z, differentiate here with respect to theta. So 2 theta plus 3 into e power minus 2z. Okay. Now replace here theta by minus 2. So the next step, 1 by 12 into e power 2z. Okay, sorry, e power 2z. If you replace theta by minus 2, you'll get z by minus 1. So minus z, minus z into e power minus 2z. Okay. So now you should convert into, in terms of x, so e power 2z minus z divided by e power 2z. So pi equal to 1 by 12 into this is x is equal to e power z. This is x square minus z equal to log x by x square. This is pi. So finally, again write y equal to cf plus p. That's over. Second problem, x square d square plus xd plus 1 into y equal to sine of 2 log x into cos of log x. So let us take x is equal to e power z, z equal to log x, xd equal to theta, x square d square equal to theta into theta minus 1. So now if you substitute everything here, you'll get theta into theta minus 1 plus xd is theta plus 1 into y equal to sine 2z cos z. Okay, now theta square minus theta plus theta gets cancelled, theta square plus 1 to y equal to sine 2z into cos z. I call this is 1. Actually, this is a second order linear differential equation with the constant coefficient. Okay, now auxiliary equation is m square plus 1 equal to 0, m square equal to minus 1. This implies m equal to plus or minus I. CF is e power 0z into C1 into cos z plus C2 into sin z. Okay, so convert in terms of x, cos z equal to log x plus C2 into sin z is log x, sine of log x. Okay, this is a CF, complementary function. So now particular integral. So how to proceed the particular integral? The right hand side is we have what? 2, sorry, not 2, sine 2z cos z.
Type 2, sir.
Sorry, type 2 is correct. Type 2
Type
correct.
2.
Type 2. So you should use the trigonometry result 2 sin A cos B. Okay, wow. The 2 sin A cos B, if you use 2 sin A cos B, you will get what? Sine of A plus B plus sine of a minus b, and then you can get it. I think you predicted type 2, that is correct. Okay. Okay, I will, sorry. Pi equal to 1 by theta square plus 1, theta square plus 1. Right hand side is what? Sine 2z into cos z. Okay. Now this is equal to 1 by theta square plus 1. So here 2 is missing. So 1 by 2 into sine of a plus b, it is 3z plus sine of a minus b. So now this is equal to 1 by 2 into 1 by theta square plus 1 into sine 3z plus 1 by 2 into 1 by theta square plus 1 into sine z. So again, type 2, so replace theta square by minus 3 square, here theta square by minus 1 square, minus 3 square plus 1 sine 3z plus 1 by 2 minus 1 square plus 1 into sine z. So this is minus 8, so minus 16, minus 1 by 16 into sine 3z. This is 0, so 1 by 2 to 1 by 0 into sine z. So minus 1 by 16 into sine 3z. So multiply here by the independent variable z. So z by 2. Differentiate the denominator with respect to theta. So 2 theta into sine z. So 1 by d means you should integrate with respect to x. 1 by theta means you should integrate with respect to z. So minus 1 by 16 sine 3z plus z by 4, z by 4, 1 by theta of sine z. That is, if you integrate sine z, you will get minus cos z. So now convert in terms of x, minus 1 by 16 into sine 3, z is log x, minus z is log x by 4 into cos of log x. So this is pi, y equal to complementary function plus particular integral. The third problem, solve x square d square minus 2xd minus 4 into y equal to 32 log x whole square, 32 log x square. So now this is type number. Which type number? You should look at the right hand side and tell.
Type 3, sir.
Yeah, type 3, correct. What is the name?
Sanjay, sir.
Sanjay, okay. Type 3. So z equal to log x. Okay, so 32 z square. So z square, that is a polynomial in z. Okay, so suppose if you have doubt, okay, so this is a shortcut method. So suppose if you have something like this, okay, so then you know that originally the right hand side is what, 32, something like that. It's x square. I think you are very familiar with the x, but you now only you are doing with z. So that's why you may not know. But if you solve 5 to 6 problems, then you can easily find out by looking the right hand side. You can tell easily this is comes under which type. Okay. So now we start as usual. X is equal to e power z, and z equal to log x. Okay, so xd equal to theta, and the x square d square equal to theta into theta minus 1. Okay, so now substitute everything in the given problem. So theta into theta minus 1 minus 2 into theta minus 4 into y equal to 32 z square. So theta square minus 3 theta minus 4 into y equal to 32 z square. So actually, okay, I'll call this is equation number 1. So this is the second order linear differential equation with the constant coefficient. So auxiliary equation is m square minus 3m minus 4 equal to 0, m minus 4 into m plus 1 equal to 0. This implies m equal to minus 1 and 4. So the complementary function is c1 into e power minus z, c2 into e power 4z. Or you can write this is c1 divided by e power z plus c2 into e power 4z. So c1 divided by e power z is x, c1 by x plus c2 into e power 4z is x power 4. So this is the complementary function. Next, to particular integral. So 1 by theta square minus 3 theta minus 4. 1 by theta square minus 3 theta minus 4. Right hand side is 32 z square. So it is algebraic. So you should write the denominator in the form of either 1 plus x or 1 minus x. I will take the least power of, I will take the constant term out. So 1 minus theta square minus 3 theta divided by 4 into z square. So this is minus 8. This is 1 minus, I think here theta is common, that's why I'll take theta commonly. Whole power minus 1. So into z square. So this is equal to minus 8 into 1 minus x whole power minus 1. Here I have z square. So 1 plus x, x is theta into theta minus 3 divided by 4. One more term I need to write. So theta square into theta minus 3 whole square by 4 square 16 into z square. Okay, now this is equal to minus 8 into 1 plus theta square by 4 minus 3 theta divided by 4 plus theta square into, if you expand this one, theta square minus 6 theta plus 9 divided by 16 into z square. Actually, I don't need theta power 4 and 6 theta cube. I don't need. So only here I need only 9 theta square. 9 theta square by 16. So on the next page I will write minus 8 1 plus theta square by 4. Okay, and then minus 3 theta by 4. Okay, and then 9 theta square divided by 16 plus 9 theta square by 16 into z square. So which is equal to minus 8 1 minus 3 theta by 4. To take 16 is LCM. 16, so 4 times 4 theta square plus 9 theta square is 13 theta square into z square. Okay, now you know that theta equal to d by dz. So minus 8 z square minus 3 by 4 into theta of z square is 2z plus 13 by 16. If you differentiate twice, you'll get 2. So we'll get minus 8 into z square minus 3 by 2 z plus 13 by 8. So convert everything in terms of x minus 8 into z is log x whole square minus 3 by 2, again z is log x plus 13 by 8. The final answer, general solution, y is equal to complementary function plus particular integral. So this is comes under which type? Log x by x whole square. Okay, otherwise I'll see how.
Algebraic and exponential, sir.
Sorry?
Algebraic and exponential.
Yes, algebraic into type 4. Type 4. Algebraic into exponential. Yes. Because, okay, I will do first, I will do the substitution. X is equal to e power z and z equal to log x. Okay, so xd equal to theta, x square d square equal to theta into theta minus 1. Okay, so x square d square is theta into theta minus 1 minus xd is theta plus 1 into y equal to log x. What is log x? Z by e power z whole square. This is theta square minus 2 theta plus 1 into y equal to e power minus 2z into z square. So you can suppose if you have like this. Okay, so this is exponential, this is algebraic. So the type 4. Okay, so this is equation 1. Now algebraic equation is what? auxiliary equation is m square minus 2m plus 1 equal to 0. So that is m minus 1 whole square equal to 0. This implies m equal to 1 comma 1. So the roots are repeated. So the complementary function is c1 plus c2 into z into e power z. So now in terms of x, cf equal to c1 plus c2, z equal to log x into e power z is x. So c1 plus c2 log x into x. This is cf. Pi is equal to 1 by, this is actually theta minus 1 whole square. Theta square minus 2 theta plus 1 is theta minus 1 whole square. Right hand side function is what? E power minus 2z into z square. So this is type 4. So first operate e power minus 2z. We should replace d by d minus 2. So 1 by, sorry, I am also doing the same mistake here. So theta by theta minus 2. So theta minus 2 minus 1 whole square into z square. So which is equal to e power minus 2z 1 by theta minus 3 whole square into z square. So now it is type 3. So you should write the denominator in the form of 1 plus x or 1 minus x. So take minus 3 commonly, that is minus 3 square. So if you take minus 3, you get 9. 1 minus 1 by 1 minus theta by 3 whole square into z square, which is equal to e power minus 2z by 9, 1 minus theta by 3 whole power minus 2 into z square. So 1 minus x whole power minus 2, 1 plus 2x plus 3x square and so on. So e power minus 2 z by 9 into 1 plus 2 x, x is theta by 3, okay, and then plus 3 x square theta by 3 whole square plus 4x cube and so on. But here you have z square only you have, so that's why I'll stop up to x square here. That is theta by 3 whole square is enough. E power minus 2 z by 9, 1 plus 2 theta by 3 plus theta square by 3. 3 square have 3, so 3 into z square. Okay, now this is equal to e power minus 2z by 9 into z square, 1 into z square plus 2 by 3. Theta of z square is 2z. To differentiate twice, you'll get 2 by 3. So let us take 3 is LCM. So 1 by 27 e power 2z, I will write the denominator. So 3 z square plus 4z plus 2. This is z. So now write everything in terms of x. So 1 by 27 e power 2 z is x square into 3 z is log x plus 4 into z is log x plus 2. So now this is your particular integral. Final answer y is equal to CF plus PA. The last problem. Solve x square d square plus xd plus 1 into y equal to log x into sine of log x. So if you know how to solve this problem, you can try. X is equal to e power z, z equal to log x, xt equal to theta, x square d square equal to theta into theta minus 1. Now x square d square is theta into theta minus 1 plus xd is theta plus 1 into y equal to log x is z, sine z. So theta square minus theta plus theta gets cancelled. This is type number. What is the type number?
Type 5.
Type 5. Yes. So algebraic into sine A z. So this is auxiliary equation is m square plus 1 equal to 0. This implies m square equal to minus 1. Implies m equal to plus or minus I. Okay. So CF is equal to e power 0 z into a cos z plus b sin z, and CF equal to a into cos z is log x plus b into sin z is again log x. So this is the CF. Now we find the particular integral 1 by theta square plus 1 into z into sin z. So this is type 5. So type 5 usually will do sin z is what? Imaginary part of e power I z, which is equal to imaginary part of 1 by theta square plus 1 into z into e power I z. So this is type 4 now. Okay, type 4. So in type 4, we will replace theta by theta plus a. A is here I. So 1 by theta plus I whole square plus 1 into z. So this is equal to imaginary part of e power I z 1 by theta square plus 2 theta I square is minus 1 plus 1 z. So imaginary part of e power I z 1 by theta square plus 2 theta I. Theta square plus 2 theta I. Our right hand side is z. Okay. Now this is type number 3. So e power I z. So take commonly 2 theta I. So 1 plus theta square by 2 theta I into z. So this is equal to imaginary part of e power I z by 2 theta. I will write the I in the numerator minus I. So 1. Here also I will write I in the numerator. 1 minus theta gets cancelled. So 1 minus theta I by 2. Theta I by 2 whole power minus 1 into z. So here I write 1 by I is minus I. Theta gets cancelled. And then whole power minus 1. So imaginary part of e power I z by 2 theta into minus I. 1 minus x whole power minus 1. So 1 plus x I theta by 2 into z. 1 plus x is enough because here z power 1. So imaginary part of e power I z by 2 theta into minus 1 multiply z plus theta of z. It is d by dz of z is 1 plus I by 2. Now multiply by minus I. You will get imaginary part of e power I z by 2 I z by 2 into 1 by theta. Okay, and then okay, if you multiply by here, you get to minus I z, minus I z minus I z I square minus plus 1 by 2. Now you should integrate imaginary part of e power I z by 2 to integrate with respect to z minus I z square by 2 plus z by 2. So take 2 commonly, imaginary part of 1 by 4 e power I z cos z plus I sin z. Here the real part is z, imaginary part is minus z square. I need imaginary, so real into imaginary, imaginary into real. So one I need imaginary. So z sin z by 4. Okay, and then minus z square cos z by 4. So this is PA, but we need to convert in terms of x. So z equal to log x to sine of z is log x divided by 4 minus z square, that is log x square cos of z, cos of log x divided by 4. So this is a PI. So final answer y is equal to complementary function plus particular. So this is a practice problem. Okay. Today I send assignment to 1 in differential equation. So try to solve those problems and submit before on or before 5th June. I think all the problems are is not direct problems. You should little bit you should think and do it. So try, if you practice these type of problem, so it is very helpful for your second CA, and you will discuss with your friends. Okay, so suppose if you don't know, so you should discuss with your friends and try to get the answer. Okay. Uh, if you have any doubts, you can ask to me. Otherwise, we'll meet on tomorrow morning. Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you so much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, ma'am. Thank you.
Thank you, sir.
Thank you.